All right, let's see what I got here. Streaming here. So it's another session where I'm working on a book that I'm writing. It is a cookbook on building configurations for EVPN VXLAN for specifically for EOS, although I'll probably expand it there. But I know EOS the best. I'm the most current on EOS right now. Make sure I'm actually live. Looks like I am. Good. Okay. So the purpose of this stream is it helps me concert actually, because I'm using you as the rubber duck. If you've ever heard of the rubber duck principle, a lot of programmers will use a concept like that where they put a rubber ducky on their desk, and then as they're working through a problem, they're explaining it to the duck, and that will help them work through their mental process. So I'm doing that, and also just practicing some streaming. Seems to be an interesting avenue. So we'll see what happens there. So right now I've got the book, and what I want to do now is lay out some concepts that I want to go through in the book. And the book parts, there's going to be a couple parts. So whenever you build an EVPN fabric, there's basically, and this is how I teach it, is that there's 4 layers. So we have the topology. So that'll be leaf and spine. Then we have the underlay. Then we have the overlay. And then we have our EVPN services, and they all build upon each other. So EVPN services. So they all build on each other, and you really, at least if I'm going to be doing a deployment, I'm going to want to make sure that I do all these from the bottom up, or at least if I'm going to verify things, I'm going to do it from the bottom up. If I'm doing this manually, which you probably shouldn't do any kind of EVPN VXLAN configuration manually in production, it should be automated. There's just too many moving parts in EVPN VXLAN to manage it reasonably by hand. But you still have to understand how things work. It's that great quote from Star Trek II, The Wrath of Khan. You have to understand why things work on a starship. And so I think that's important there. So in the topology, the things that I talk about are more design elements. So, oh, by the way, yeah, should I be going back to I think I should be doing there's a style. So for years, whenever I've done, actually, you know what, I should do this. I was going to do this, white text on black background, or white text on dark background. But here I'm doing the more traditional PowerPoint style, which is black text on white background. All right. So, so the topology part, the big thing there that will affect a deployment is going to be MLAG or EVPN all active. And then how many spines. So these are the kind of decisions you make when you're building out the topology. And single pod or multi-pod. So single pod would be known as a 3-stage CLO, or multi-pod, which would be a 5-stage CLO. So those are kind of the decisions you're going to make, is how many spines, how many leafs, how many connections between leafs and spines. So there's some decisions you'll need to make, some architectural decisions, but they're pretty straightforward. There's not a lot of, it's just knowing your requirements. How many leafs do I need? That'll be dependent upon how many front-facing ports I need. Most leafs are going to be like a 25 gig downlink and then 800 gig uplinks, or however many 400 gig uplinks, depending on the model. Are you going to do MLAG or EVPN all active? So that'll determine whether or not the leaf pairs would be connected to each other. If they were doing MLAG, if it was EVPN all active, they don't need to be connected to each other. How many spines? Generally, you're going to have 3 or more in medium to large size deployments. If it's a smaller deployment, you might just do 2. And if you have a smaller deployment and you're only going to do 2 spines, you might want to consider just doing layer 2 only. So just doing a traditional collapsed core, because EVPN VXLAN brings some extra complexity here, but we're not going to talk about the other styles. Underlay, basically you're going to figure out what routing protocol you're going to use for the underlay. And we're going to assign loopback addresses to nodes. Nodes are leaf spines and super spines. And provide connectivity between loopbacks. That's all the underlay does. So I think a lot of people tend to make it more of a complex, make it more complicated than it really is. It's which routing protocol do you use? We could use IBGP, EBGP. Let's start with EBGP because that's kind of the default. IBGP, OSPF, ISIS. You could even do static routes or RIP if you wanted to, but those are terrible choices. But any of these will be good. The default that Arista recommends is EBGP. And then the overlay, it's also really simple too, is we're just going to peer between, it's an EVPN peering session. So it's an MPBGP peering session that is independent of the underlay. So if you're running BGP for the underlay, this configuration is independent of that. The only correlation is if you are doing BGP for the underlay, your overlay would be like, if it's IBGP for the underlay, then your overlay would be IBGP and vice versa. If it was EBGP, it would be EBGP. Between loopback 0 of the spines and leafs, and loopback 0 of the spines. Very simple, very easy. Well, maybe not very easy, but that's pretty simple to do there. And then the EVPN services, that's going to be things like VLANs, stretch VLANs, Anycast gateways, VRFs, external routed connections per VRF, and VNIs, IRB config. So those things, that's the stuff that'll get the most complicated. So this cookbook is going to have it'll either briefly talk about the topology, like we don't have to talk, it's not an EVPN VXLAN book, although maybe it'll morph into one. But we don't have to talk too much about the topology because that's usually pretty well determined. It's just whether or not you're going to use MLAG or EVPN all active. Because we're going to want to multi-home our host. We're going to want to connect our host to more than one leaf. With MLAG, we can connect up to 2. With EVPN all active, we can connect up to more, although we generally don't. So this will be EBGP or IBGP. And so these are the things. And what I was going to do is I'm going to start out with the underlay. And for the underlay, I just want to build some configs, and I need to document them. So underlay configs. Now, there's 2 purposes for this book. One is to provide configuration examples for planning production environments. And the other one, or at least to understand what they are. And the other one is to help pass the L3 exam with Arista. So Arista has a certification program called the ACE. It's the Arista Cloud Engineer program. There's 5 or 7 levels. I'm level 7 certified. I helped write some of them. I helped write the level. Actually, I wrote all of the current L5 version, all the current automation version of the courseware. I have not had anything to do with the tests, at least in a long, long time. So many, many years since I did the test. So I have no idea what's on the test today. I know they've done new versions of the test, so I don't know what any of the tests are. So I'm not, and even if I did, I wouldn't put anything in here, but I don't. So it's to help you out. And now having configuration snippets is not going to help you pass an exam if you don't understand the core concepts. So you should understand the core concepts of EVPN, VXLAN in order if you're going to take one of these tests. But the level 3 exam is one of the biggest parts of level 3 with Arista. If you take that course, there's video on demand and there's instructor-led training, is talking about EVP and VXLAN. So a good portion of that course is dedicated just to that particular technology. So a lot of people will end up taking that one. I think that's the most popular class. And I think automation is also pretty popular. Level 4 is more like service provider, so like MPLS. But level 3 is more like EVP and VXLAN, data center stuff. And level 5 is automation. So we go through AVD, Ansible, a little bit of Python, that kind of thing. All right, so underlay configs. What I want to do is I want to show basic eBGP IPv4 underlay. So what does that look like? That's the default. We'll talk about defaults. And when I talk about defaults, I don't mean like the configuration defaults. I mean what does Arista recommend? Their kind of default for an underlay is to do eBGP. So if you're not sure what to do, then that's what you should do. You should do what the vendor says is their default. But it's not really it's not really a big deal if you choose another one of the routing protocols. If you choose OSPF or ISIS, if you take an exam, like all of the Arista exams are practical, which is really cool. And that you get a list of things to do, and then you have to complete them. And one of them might be to set up one type of underlay or another. So I don't it's been a long time since I took any of the tests, and they've changed since I've took them. So I don't remember what was on them. And if I did, it wouldn't help anyone. But theoretically, you could be tasked with creating an OSPF based underlay or an ISIS based underlay or something like that. I don't know. It really depends on what the test writers are doing. And I don't have any insight into that. But to do some underlay configs, so there's eBGP with an IPv4 underlay, then there's eBGP with IPv6 RFC 5549, which is really cool. It's basically IPN numbered. There's OSPF numbered, OSPF unnumbered, and then I'll do ISIS as well, probably unnumbered. I think probably the biggest benefit to doing OSPF, I always recommend if you're gonna lab EVP and VXLAN to use OSPF because it's the simplest of the routing protocols. Throw everything to area 0, do point-to-point connections, IP numbered, and then you're golden. So actually, I might do that one first because that one's the easiest. And I've got an environment here, and it's up and running. Let's see if there's anything on them right now. Good, they're blank. The other thing I'm going to do is I'm going to use automation to generate a full config stack. The topology I'm using is one of the Nerd topologies from Project Nerd. And Project Nerd is like just some instructions to build some home labs. That's all Project Nerd is. So it's on GitHub. And this is the topology for this. And the idea was to start, if you can create a virtual machine with 16 gigs of RAM and 60 gigs of storage and 4 virtual CPUs on x86, whatever hypervisor you want to use, then you can build out this topology, leaf spine topology, using Container Lab and some other tools that are all... So it's just a set of instructions on how to make this system. So install Git, install something called Code Server. Code Server is really cool. It's VS Code running as a web app. So this command line I've got right now is actually running on a VM. It's not running on this Windows desktop. So it's running as a VM, and I can edit files and with this VS Code web app, and it's really cool. It's just a simple set of instructions, narrows down the tools, narrows down all the different things, and you go if you can download an ISO from Alma Linux, and all of this is running free, so you don't have to pay anyone any money to do any of this stuff. You'll have to pay for your hardware, of course, but you don't have to pay for anything else. So it's all either free or open source and free. So we're using Container Lab, which is open source and free, and we're using containerized EOS from Arista, which you can download and use in a lab environment for free. And it's not like you have to find an image that fell off the back of a truck. I mean, I think we've all been there. But here, you don't have to do that. Just download it off of arista.com. All right, so I'm going to do the IPN numbered, and I'll do a quick config from the leaf to the spine. And I'm going to try to keep things consistent on my config here. So I'm going to capture this. So I've got some diagrams I can use here. So underlay OSPF. So the nerd topology has 3 spines and 4 leaves. It's got 2 hosts and an external router, but we don't need to deal with that. So spine 1, spine 2, spine 3, leaf 1, leaf 2, leaf 3, and leaf 4. We do have connections between them. Man, Microsoft really wants you to use that Copilot because they're putting the button like right where so they are connected to each other. And every leaf in a topology like this is connected to every spine. At some point, I'll make some multi-data center or multi-pod topologies so people can practice. Arista does have a really nice containerized implementation of their network operating system. It's the best in the industry, because Cisco and Juniper do not really have a good containerized platform. Juniper has CRPD, but it's an older version and it's not really supported, and it needs some licenses that are hard to get because you have to actually get a license for something different for that license to work. So if you want to do labbing with it, you're going to want to download one of their VMs, which is going to be, it takes up a lot more RAM, a lot more CPU. Same thing for Cisco. If you want to play around with EVPN VXLAN for Nexus, you've got to download the Nexus 9KV, 9000V, and that's a beefy VM. So I can run all of this plus 2 hosts and an external router. External router is not really a real router. And I can run that in 16 gigs of RAM. I cannot build this topology with Juniper or Cisco on 16 gigs of RAM. You need way more. Or you just have to have a smaller topology. Because these are all pretty lightweight. Each one of these containers, if you get the non-64-bit version, it takes up about a gig of RAM per container. and that's really light. Cisco and Juniper take up about 5 to 7 gigs depending on for each one, and they eat up a lot more CPU. All right, so I want to keep things consistent. So I'm going to come up with a numbering scheme for things like loopbacks. Whatever underlay I choose, they're all going to have loopbacks. The rule is, well, it's not a rule. By convention, loopback 0 is used for EVPN peering, and loopback 1 will just be on the leafs, and that's used as a VTEP. Although if we were doing EVPN all active, we could also use loopback 0 as the VTEP address as well. But I think it's good to separate them out. Gives us a little bit more flexibility. So loopback 0 will be 10.1.55.101. So loopbacks are /32s. Change the fonts there. Make these kind of small. I'm streaming in 4K now, so should be not too bad to read this. I don't think you can zoom in though on YouTube. So I'll just use the arrange, and I'll arrange them. There we go. And then over here, do 11. Let's do 1, 2, and 3. Yeah, 1, 2, and 3. This one's 4. And then if we're doing MLAG, so the loopback 1. So here's how do I want to handle this? If we're doing MLAG, loopback 1 is shared between the leafs. If we're doing EVPN all active, then loopback 1 is unique. So I'm not really sure how to represent that. So I'll just do MLAG, and then here I'll do EVPN all active. Now we don't configure EVPN all active at this point. Just what is the underlay set up for? And technically, if we're doing EVPN all active, we probably wouldn't even need a loopback 1. We could just use loopback 0. The reason why we have a separate loopback 1 is because that has to be identical between leaf 1 and leaf 2. Because with MLAG, they pretend to be the same. VTEP. And that's what you want for MLAG. For EVPN all active, it doesn't matter. But both of these will let you multi-home hosts, which is generally what you're going to want. So I will do the simplest one is just EVPN all active. So I don't really have to do much. And from a raw configuration, oh yeah, and we'll do we want to do unnumbered? Yeah, I like doing unnumbered. So loopback 0 for leaf 1 is 10.1.250 IP address 10.1.255.1/32, and then we'll do IP routing, router OSPF 10, router ID 10.1.255.1. So we're going to make loopback 0 be the router ID for both BGP and OSPF, or whatever routing protocol we use. They generally want a router ID, and we're going to give it one. I've run into weird problems if we have identical router IDs. OSPF area 0. Oh yeah. So the other really nice thing about OSPF, that's it for the routing protocol. We just give it a router ID. That's it. The max LSA is automatically there. And then interface loopback 0, we'll do IP OSPF area 0. And then we might want to be passive. I don't think it really hurts if it's not. It's always worked if it wasn't passive. But I think best practice would be to router OSPF 10 is interface loopback 0 passive interface loopback 0. Yeah, so that's it. And honestly, I've not done the passive interface loopback 0. I've never done it, and it's been fine. So, yeah, so we'll do that. And then for the interface, we have 3 spines. Or actually, we have 2. Do we have 2 or 3 spines? I thought I had 3. Let me check. I'll check the topology. Yep, well, we just have 2 spines. Okay, that's fine. I thought I remembered 3. So they're on Ethernet 3 and 4. So I can do Ethernet E3 through 4. IP address, no switch port. IP address unnumbered. And you have to specify which loopback you're going to borrow that address from. IP OSPF area 0, IP OSPF network point to point. So the network point to point will tell it to not elect a designated router or a backup designated router, because we don't need to, because there's only 2 routers on the segment. And that should be it. It's a real simple config. That's why I love doing it for this kind of thing. And then go to spine 1. Admin at spine 1. Might want to add some. One of the things I was going to do was to build some automation to dynamically generate these configs. So I need to create some initial configs first, and then I'll put it into a Jinja template. And that way I can bounce between all of these different topologies by just running a playbook. Then I can upload them. So I'm going to want to bounce between eBGP as an underlay, eBGP with IPv6, RFC5549 as an underlay, OSPF numbered, OSPF unnumbered, ISIS. I want to be able to bounce between them. So the best way to do that is I could type them all out by hand, but it would take a long time to type all these out by hand. So I don't need these. It would take a long time to type them all out by hand. Or I can just create a template, and then it'll just generate. It'll take some more time to create the template, but it'll automatically generate the configs, which is perfect. So that's, I think, what I'm going to do. Fix that. Okay. So that looks good there. But I just want to get the prototype up, make sure that I've got all the commands that I need. And so that'll be config, IP routing, interface, loopback 0, IP address 10.1.255.102, IP OSPF area 0, router OSPF 10. The 10 is a process ID. It's locally significant. You just have to give it a number. Between 1 and, looks like it's a 12-bit or 16-bit number. So I just default to 10. Doesn't really matter. You can only have one instance of it, as far as I know, and you just have to pick a number. And you could pick different numbers for different devices. They don't need to match. In fact, you couldn't tell if they match because, again, it's locally significant to the device. Router ID 10.1.255.102, and then we'll do passive interface loopback 0. Interface E1 through 2. Wait, show LDP neighbors. To all the leafs. So interface E3 through 6. Spine 1 and 2 are connected to each other, and that's for other types of topologies. In EVP and VXLAN, the spines are generally not cross-connected. There's not really any good reason to that I know of. Maybe someone in the comments will, video comments will correct me on that, but I don't think there's any good reason to do so. All right, so no switch port to turn it into a layer 3 port, IP address unnumbered, loopback 0, IP OSPF area 0, IP network, IP OSPF network point to point. So if I do watch 1 show IP OSPF neighbors, we should see them come up. So another thing the cookbook's going to do is going to have here's how to configure it and here's how to verify it. Now, if I was building one of these in a lab environment, oh, look at this. I see it across. That's because they're layer 2 interfaces. Yeah, this is a weird bleed through of broadcast packets by the nature of the underlying by the nature of the underlying virtual switches that are connecting the containers together. So you shouldn't see it like that. But I'll show you the different show commands to verify this. So in my book, you got it, VS Code. So I'm writing it all in Markdown, and I do need to sync up. I think I just added 2 images. I didn't like that. See if I can do a pull. I'll deal with that later. So I've already got some of it already done. So underlay, underlay there. So routing protocols, just talk about that kind of stuff. Some of that's already on there with IPN numbered. So after I already got these in here. I do want to put in the passive. Yeah, OSPF. To make sure I put that in there. Yeah, and then if I do a show IP route on the spine, I should see an entry for the leaf. Okay, so that's good. So now I want, under Ansible, I want to create a template. So I'm going to create a templates directory. Templates. And then I'll do OSPF. I'll do underlay and then OSPF unnumbered. And it's just for this environment. So what do I need? I need a config. Oh, there's another thing I want to do. I've got these already set up. So I will open up Clo Medium. I'll go to Ansible. A couple of things the setup nodes does. There's a playbook called setup nodes. It creates a user Tony. And Also does some authentication stuff. I don't need that. Terminator, yeah. Make sure my inventory is correct. This will make it so I can log in without a password. Excuse me. I'll be right back. I'm going to grab some water. I had some popcorn on. Excuse me. I had some popcorn earlier today, and I think I got a kernel stuck in the back of my throat. Okay. Excuse me. All right, so that's all done. So should be able to SSH into. Yeah, so that's nice. So that's the baseline config I want. So I wanted to include the SSH keys. So I have this simple playbook that I use in my lab environments that creates a user Tony and puts in the SSH key in there so it can log without a password challenge. And then just use these commands, which just drop me right into privileged exec mode without having to type in enable. All right, so my underlay. So I'm going to take a config. I'll take the leaf here. And paste it into here. And that's fine. That's good. Just to find out the parts that I need to replace. So that would be this. So since it's a Jinja template. Oh, I need to install a Jinja extension. So Jinja. There we go. There we go. So this will be the comment thing or comment section. This will be a loop through physical interfaces. And then we'll do end loop. So what Jinja is going to do is I'm going to have a data model that will have a list of the interfaces that are going to be point to point, and then that'll generate those configs. So this is a lot of automation for this, but it's going to make my job a lot easier down the road. Then I need to do a loop. So loop through the loopbacks. Loop through loopbacks. The spines will just have one loopback. The leaves will have two. Loopback 0 and loopback 1. And I've already done something like this. So Melissa's work is actually already done for this part. So I'm just going to copy it. And that's in my GitHub repo. It's me skydiving right there. It'll be in Project Nerd. No, it'll be in Nerd. My my Jinja template demo. So where's my template? Oh yeah, I'll need a data model too. So let me copy this. I'll just paste it over. So when I generate configurations using Jinja, you have two things. You have the data model, and then you have the template. The template will fill in the blanks or loop through different things based off information in the data model. So normally the person after it's set up would just interact with the data model. And so yeah, so that'll Ansible. I need group vars. And then we'll create a group called fabric.yaml. I'll put in that data model. Something I definitely want to fix here. The default to VS Code is to do this thing here. I can't remember what this is called, but it's really annoying. Tiling, maybe that's what it's called. There's a way to disable it, and I've got... That's not in there. Pulling this from another setup I've got. I have lots of workspaces, lots of virtual machines that are running various implementations. There we are. So I'm going to copy this, and then I'm going to go into my settings and find the link to JSON, edit settings.json, and just replace the whole thing. There we go. So that's better. So now when I scroll down, it doesn't do that stupid tile thing. I don't know why that it does that. All right. So I've got my thing here. I've got, so these are all parameters, all the information that we need to build out a config for an underlay. So I've got it all here. I did change the loopbacks. Did I want to do that? Now I'll 255 1. Change those loopbacks to make them consistent with my design. Did I need... I think I hard-coded them. The subnet mask, because the loopbacks are always going to have a subnet mask of /32. So I think I hard-coded them. All right, so we'll rename this to, I need to be consistent here. So fabric, that'll be underlay OSPF unnumbered. Oh yeah, we're going to do all active, because there are going to be several flavors of these. All right, and then I've already got a template. So this is from my free YouTube course on automating with Ansible. I just need the loops. So this should, what it does is it loads up a dictionary from here, which is loopbacks, and then goes through each one and configures that loopback address. Yeah, we did hard code it, so I don't need to have the sys32 in there in the data model. All right, so that's good. And then for the physical interfaces, I'll copy this. And I also have to configure host name. Because what we're doing is we're replacing the entire config of the device. So whatever was there before is not going to be there anymore. So to refer to Star Trek 2 again, this is going to be it's going to be like the Genesis torpedo. So if like, for example, if I forget to put in a management address, I'm going to lock myself out. So I don't want to do that. I don't want an IPv6 address because I don't care about that. It's one of the problems you run into with Container Lab. It's IPv6 by default, but if you don't put an IPv6 address in there, and it's in DNS, it'll time out. It'll take like 6 seconds to connect to anything because it's trying the IPv6 address first, and then if it's not responding, then it'll go to IPv4. There's different ways around that. So for management, I need this. Yeah. Oh, not that. I do need to loop through the passive interface here. So this needs to be loop 2. It's not in this here. Oh yeah, so there should be. Put that in there. Did my data model have it didn't have an instance number. We just hard coded it to 10. That's okay. Some things you can hard code and it's fine. So this will be a loop for passive interface. Again, I'm kind of doing a little nitpicking here because I've never really had to do this. I'm just going to leave this, see if we can generate a config for now. So this has to work. This has to be the entire config. So anything that's on the device is going to get erased by whatever this is. So that's why it's especially important to make sure that we have the management interface configured. So I'm going to check, I'm going to run the playbook. So I'm going to steal a playbook from this. Build OSPF on AA.yaml. Might be a better way to do all this in terms of think that'll work. All right. Let's see. Devices is undefined. Devices. Oh, it's there. Oh, shoot. So what I need to do is, so that's not really a group name. So what I'm going to do is move that to a directory called vars. And what I'll do for the playbook is vars files. I think if I do that, that should work. Destination directory does not exist. Okay, so I just need to make a configs directory. There we go. And we'll take a look at the config. That looks all good. Then I'll deploy it. And the reason why I'm generating all these configs, I could type this all up by hand, but it's going to take forever. I mean, it's not going to take forever, but it's a lot of cutting and pasting, and I'm an automation engineer, so might as well just automate all this. That way I can bounce it back and forth between all these different configs. And that'll be fine. Let me check something here. Okay. And then now that we've got the configs, and what I'll just check to make sure is there a management interface? Because if there's not, that's going to be very difficult to configure. Also, I'll go into Etsy hosts. Just make sure there's no IPv6. Yeah, there are. So I'll show you what happens. So let's go to leaf 1. If I do config interface management 0, no IPv6 address. And then I go to leaf 1 again. It's because in DNS, or in Etsy host rather, it's trying to reach leaf 1 via its IPv6 address, but it's not responding. So it times out, and then it switches to IPv4. So it takes a long time. It's like 7-8 seconds. Or even longer. Usually it will try. So what I do is I just delete the IPv6 addresses. The other thing to do is under the actual config file here, there's a way to just disable IPv6 entirely. Not that I have a ton against IPv6, but yeah, so we create our network and we just put this in here. And then the next time we deploy this, it won't have any IPv6 addresses. Okay. But the erasing it from that will do for now. All right, now I want to deploy these. It's doing that thing here. Extensions, settings. What is it called? Guides. Font ligatures. Open repository. Paraphone. Windows menu. Enable multi-line pasting. Color theme. Confirm drag and drop. Something else. It's in the workbench. Let's let it. Sort order. Oh, is it collapse? Oh, no, that's not it. It's when it does this, whatever. I can't remember what it's called. Thought I disabled it. Fonts. Sticky scroll. That's what it's called. So there's a sticky scroll here. And I need to erase that. So sticky. There we go. Oh, that was bugging me. Okay. So now I want to push these. So I've got a playbook here that'll do the deployment. So let's deploy OSPF all active YAML. So configs are named by that underlay OSPF on AA. Save it always, and then y'all make some backup configs. Put them in the wrong directory. There we go. So Ansible playbooks, deploy. This pushes them via EAPI. So this worked. I'm locked out. I just have to start a new session. So if I do show IP interface brief or show IP OSPF neighbor, I should have, yep, I got full to the spines. Show IP interface, show IP route. And so I should have, yep, I can see all of the leafs there. Yeah, there we go. So all of them should have two paths. So I should see those two paths there. I didn't see one for a second there. Because it's equal cost multipathing. So it should go up like leaf 1 should have two paths to leaf 2 and two paths to leaf 3, two paths to leaf 4. That's what we've got. So now I can do the verification commands. So for underlay, so these are there. And oh, I have to add loopback 1. I didn't do that for this demo, so I've got to add loopback 1. So on my vars file, the leafs will have a loopback 1. The spines won't have loopback 1. They don't need it. Because loopback 1 is used for VTEPs. So we have to encode that into this. I think that'll be pretty easy. Yeah, it should generate automatically. Let's do build. So you can see it changed leaf 1, 2, 3, and 4, but it didn't spine 1 and 2 because they don't have a loopback 1. So let's see if we configured a loopback 1. We did with an IP address. It's put into OSPF. And then we just need to add this in here under passive interface. Again, I don't think we need it, but like it might be one of those persnickety things that they're like, oh, it's got to have this thing in there. So we'll just put it in as best practice. What's under here? So we need to loop through the loopback loopback interfaces. To look like this. So for loopback and devices, we'll do end loop, N4, passive interface. I think it's just LO. I think that would do it. Yep, that's all it took. All right, let's deploy this. So it looks good. Now I've got, do I have 254 in there? Yeah, I do have 254. I'm not getting loop 4. Did I mess up the... See if I... garbage in, garbage out. So if you don't do it right in the... Yeah, I did. I messed it up. So it should be 4. So... Build. Deploy. So that should be fixed there. We should see 4 come up here. There it is. All right. So that's an underlay. That's the simplest one because all active doesn't require us to. MLAG requires us to do an OSPF session between the two leafs. Where does it? I think it's only per VRF. I don't remember. We'll just leave that for now. I can't remember if I need to do this per VRF. One way we can check is what does AVD do? Because that's Arista validated designs. So I'll upload up another demo that I've got running. So this is a different VM. My live demos, AVD. So I just tell AVD that I want it to build use the underlay routing protocol. I'll do OSPF. I'll make sure I've got 2 VRFs configured. So see if, because I can't remember if I need to peer once for the underlay or per VRF. I think it's just the underlay, but this will tell me for sure. EVPN services. Yeah, let's create another VRF. VRFB. We'll build that. Oh, I need an uplink pool. Did they add anything for unnumbered? Let's see, for AVD. For OSPF. Under designs. Yeah, it doesn't look like they've got the ability to do OSPF unnumbered. They can do IPv6 unnumbered, but so we'll have to do that. That'll be fine. All right, build the configs, and let's check out what's intended. Oh yeah, it's they do it. Do they do it in the overlay? M3M lag. I think they do it in the overlay. So I don't have to do it in the underlay. Let's deploy it and see what happens. Oh, am I not running any sudo container lab or sudo docker ps? Yeah, not running anything. Okay, we can fix that. Gotta wait for them to come up. It's not something you have to do for all active, but for the next one, for the underlay, I would have to peer between leaf 1 and leaf 2, and I think it's just once for the verification commands, because we want to configure, then we want to verify. We always configure verify, and when I'm building out these fabrics, I build the topology, then verify it, LDP. I do the underlay, verify it, show commands, overlay, do it, verify it. I don't move on to the next step until I've verified the previous steps. I think that's probably best practice. Loop back. The device is a leaf. If the node is a leaf node, then both loopback 0 and loopback should be passive. One thing about writing a book is you have to be consistent about how you do things. Like, do I make the loopbacks capital in the text? So I haven't been, but it is capitalized in the config. Yeah, so we'll do that. All right, this should be up and running right now. Over here, yep. So try deploying that. Got that. There we go. Yeah. Okay, so yeah, we don't have to do that. Okay, we just need to do it once. That'll make things simpler. All right, so I've got that one done for the underlay. So, and we want to go on to the configuration. We don't need to do that there. And now we do verification. So we'll have a section OSPF with unnumbered, all active. Let's describe what it is. OSPF, a very similar routing protocol. OSPF come the loopbacks. Can use both MLAG and EVPN all active for multi-homing endpoints. With MLAG, the MLAG pair will need to be connected via a peer link, typically two front-facing ports, such as 25 gig. Is that true? Let me try it. Let me check this out. Pure link, MLAG, Arista. Sometimes I check my assumptions to make sure I don't make anything, do anything wrong here. Oh my! Oh, my background's fallen. Still working on getting a better, more permanent solution for the background here. Because right now I'm just taping things. Okay. How much bandwidth do we need? I think most of the time it's fine because data plane traffic shouldn't traverse the peer link unless there's an orphan port. There's ways around that. So it doesn't really say in here. My assumption is just use the lower speed ports because we're just syncing up traffic between them. It's not syncing up traffic, syncing up addresses. So if an Ethernet frame, a MAC address is learned on one leaf, it's shared with the others. Because what MLAG does is it takes two switches and presents them as the same switch from a layer 2 perspective. So that's okay there. Oh yeah, we're going to verify. Ports should be used for redundancy. In some cases, bandwidth may want to be increased, depending on how much bandwidth may be used in certain failure scenarios. That'll be a good catch-all. That'll keep you safe. So to show a simple underwear configuration, here is between leaf 1. Okay, so that's good. All right, so let's do verify. So verify OSPF underlay with EVPN all active. EVPN all active wouldn't be verified here, as that's all configured in the EVPN services. The purpose of the underlay is to, well, remember the purpose of the underlay is to provide IP connectivity between loopbacks. And that's it. To verify this type of underlay, you'll want to check to see that all OSPF neighbors are established. Check to see all loopback zeros and loopback ones are in the routing table, the default routing table. Because the underlay is done typically in the default routing table. Check to see multi paths to those loopbacks. Because that's all pretty much it. So if I go into a switch and I do show IP OSPF neighbor, I can see that my state is full, so I have a neighbor relationship. Adjacency, we would call it adjacency. Yeah, so verify OSPF neighbor adjacencies. That would be simply show IP OSPF neighbor. Copy and paste. Now Markdown has a couple different ways we can handle these kind of things. I could do, oops, I need to put it up here. So I like doing just standard HTML. That seems to work the best because I can do things like bold to show that I'm doing that there. And I can also do colors, like turn it red, which I forget how to do. HTML red text. Like this here. Do red to highlight the full. Make it bold. So we can do a open preview. There we go. See, yep. So that's bold. Maybe I want to do blue. The color there. I'll make these just to call them out, make them easier to see. See what that looks like. Ooh, that's harsh. I want a lighter blue. So maybe AA. Oops. No, I don't want that. It's a baby blue. Eight, 9, Charlie Foxtrot, Foxtrot 0. Let's try that. That's better. I want something that's got good contrast, so that looks good. And I want to add 1, 2, 3, 4, 4 spaces here. Got so many different VS Code windows open. It's interesting that it takes a second to render. I wonder why that is. All right, that looks good. So verify that when the routing table, show IP route. Do it from a leaf perspective. call it a day here in a little bit. So copy this. That needs to be a pre and unpre. If you have to see that the loopbacks are in the routing tables of each device. There's an ANTA, so ANTA is a testing framework for Arista. You could use that also to do like mass verifications. AVD does it by default for several types of tests. Not all of them, but for most of them. If there are 2 spines, there should be 2 routes, not routers, to the same loopback. There should be. If there are 3 spines, there should be 3 routes. With OSPF and Arista EOS, ECMP is on by default. It's not for BGP. So for BGP, you have to tell it that it can use multiple paths. But OSPF, if it's ECMP equal cost multipathing, we'll see it there. All right. And then what else would you want to do? Want to check to see yeah, so that does that. So command is simply show IP route. Now, if I do it, I grep for 32. Well, yeah, that's better to see it this way. Okay. I thought it might save some room by just grepping for the /32 route, so we only see those, but that's fine. The spine, the routes will look different. Each spine should have as many paths to the leafs. Well, let's see what it looks like from the spine. These are our leaves up to the, what's the ECMP limit for Arista? What's the maximum pass? 16. And it depends on the platform. Like, and some of these aren't even like there's Trident 3s now, so I don't know how many those are. The spines don't really need to get to each other. They're loopbacks. All right, I think that's it. I got one topology type done for configuration and for verification. So think I'll wrap that up for here for today. Hope you enjoyed. I'll probably do more of this tomorrow. I'm going to try to knock out this whole book in a week, and let's see if I can get done by Friday. That might be a little. We'll see. Normally, it would take a lot longer to write a book, of course, but I know how to do all these configs. It's just getting them all into templates and spitting them out, and then it's kind of a. It's not a text-heavy book. It's a configuration cookbook. So it's just going to have configurations in them and some explanations. So I might be able to get it done in a week. We'll see. Anyway, I hope you enjoyed, and I'll see you next time.